Hello guys, I am Nidhishri Bagalwadi, Sankalp Learning Solutions, your science teacher. So in the last class, we learned regarding the object distance, the image distance, as well as we learned regarding the nature of images in the concave mirror when an object is placed at several positions. Okay, so related to that, we are going to learn regarding the relation between the focal length, object distance and image distance. uh, According to your syllabus, you don't have the derivation of that formula or the relation whatever I am teaching now. Okay, so you have direct formula will be there. So based on that, you will get the numerical problems. You don't have any derivation. So after completing this chapter in the upcoming sessions, if I get the time, I will derive that formula. Okay, so here based on the image, object and the focal length, there is one relation between these three factors, that is 1 by v plus 1 by u gives you 1 by f. So here we can say the reciprocal of image distance and the reciprocal of object distance. The sum of reciprocal of image and object distance gives us the reciprocal of focal length. Okay, so by this we can say that V is nothing but the image distance. Image distance means the distance of an image from the pole of a spherical mirror. Okay, yes. Then U represents a object distance, right? Then F, that is nothing but a focal length. That is the distance between the pole and the principal focus of a spherical mirror. So using this formula, we can calculate when any two values are given. So if V and U are given, we can calculate F. If F and U is given, we can calculate V. If V and F is given, we can calculate U by the mathematical operations. So which are the mathematical operations? I will just show you. So if you want V, okay, so you can see 1 by V is equal to, so when this shifts here, this is a left hand side, right? And this is a right hand side. So when a plus sign shifts here, obviously it will become subtraction. 1 by F minus 1 by U. This is when we have to get the image distance. So if you want the object distance, you can see 1 by U is equal to 1 by F minus 1 by V. Okay, so these are the two mathematical operations by using which we can find object distance, image distance as well as the focal length. Okay, next, in the last session I discussed one of the case where when we place an object near to the pole of a spherical mirror through a concave mirror, so we got the image which is magnified. So what is that word magnified means? Which is larger in size compared to an object. Okay, so the magnification is denoted by a letter M. So to find the magnification, we have one more formula which is nothing but the magnification is given by the ratio between the height of an image, which is denoted by small letter h dash divided by small letter h dash by h. H dash indicates or represents image size, or we can say the image height of an image. Okay, h dash, and the h represents height of an object. Height of an object. Okay, so here height of an object. So here we can find the magnification of an image by providing or by giving the ratio between the size of an image and the size of an object. If we know the height of an image and height of an object, we will get the magnification of that image. So these are the two main formulas on which we will be having certain numerical problems. Next. might be knowing that while we were studying the nature of images through concave and convex mirror, you might be knowing why we have to learn these all. What is the use of it? So we have to learn because we are using these characteristics of mirrors in our daily life, where we will use. Suppose if you have a car or else a two-wheeler at your house, okay? So if you are driving, if you completed your 18 years of age, you will get the driving license, right? So here, if you are driving, you can see the rear mirror in your two-wheelers as well as in your car. So on the rear mirror, there will be written that objects in the mirror appears to be closer than they appear. Okay, appears to be closer. Okay, so what happens there? Objects will be closer but they appears farer. Where we will use this application? See here, when we study the applications of a spherical mirror, okay, the first one is a convex mirror. So in the convex mirror, what will be the nature of an image? The nature of image is, it will be erect. That is how the object will be. If it is upright, the image will be also upright, erect. It is diminished, means it appears small. And it is virtual. It is not obtained on a screen, usually, right? This is the nature of the image. So this property we will use in the rear mirrors of our automobiles, that is car and the two-wheelers, right? So if you want to see the vehicles which are behind your vehicle, so those will appear very smaller, that is diminished image, and those are erect. How they will look? Straight. They will look straight only, not upright or ulta, we can say. And those will appear, as they are very small diminished object, they are longer, they are very far from your vehicle. For example, when you see the things which are far, so the things will appear very small. Okay, that is eyesight. So the things which appear very large, those will be very near to our eyes. Like that, as the image will be diminished, will be smaller, the distance between your vehicle and that vehicle appears what? It is far. But no, that is not the case. So usually that image or that vehicle will be near to your vehicle only, but it appears it is far because it appears small. The image appears small. That is why they will be written on the rear window, that is caution. Objects which appear in the mirror will be usually closer than they appear. They will be usually closer. How they appear? No, they are not so far. They will be closer to your vehicle. Okay. So this is the application of a convex mirror. Next, on the roads also, when there will be a sudden turning and all, you can see a certain mirrors which will be hanged on the road. So those mirrors also uses this convex mirror, right? Then we have one more mirror, that is a concave mirror. So in the last session itself, we discussed regarding the concave mirror. That is, when an object is placed near to the pole, very near to the pole of a spherical mirror, the object appears magnified, very larger in size than the object. An image appears magnified than the object. So that property or that nature of concave mirror is used by the dentist. It is used by the dentist, okay, to check our teeth. So when you go to the dentist, you can see that they will use a plate-like structure which will be having a holder, and that plate-like structure is made up of a glass. So it is not actually a glass, it will be having the concave mirror, which make them easier to see which teeth has been defected, what problem we have in our mouth. That is a concave mirror. Then it is also used as a shaving mirror. concave mirror is also used as a shaving mirror. Why? Because the nature of concave mirror is when an object appears very closer, when the object becomes very closer to the concave mirror, so that time the object will not be inverted, it will be erect, and the image we will get the magnified image. The image will be erect and magnified. But the actual nature is we will get the inverted and diminished image according to concave mirror. But when we change the position of an object, when we bring an object very near to the spherical mirror, that time we will get the magnified image as well as the erect image. So that property is used by a shaving mirror, so that whenever a person will be shaving, that will be a clean shave. A magnified image will be formed which helps them for shaving. So these are the applications of the convex mirror and the concave mirror. So till now we learnt regarding the property, one of the property of a light, that is reflection, and then we learnt regarding how the reflection occurs through a spherical mirror. In the upcoming sessions we will be discussing one more property of a light. Okay, then we will be discussing certain more optical instruments which are used in the light concept. Until that, observe science, learn science. Have a nice day.